Hi, it's Sam. In this video, we're going to continue looking at advanced MIDI sequencing by looking at timing using phasor and adding swing. So let's just create a simple setup here with just one object. We're going to use the phasor using for_n at lock 1. So this will be sending out quarter notes, and when we turn lock 1 on, phasor will only run when the transport is on, and it will lock to the position of the timeline. So these quarter notes will line up with where the quarter note divisions are in the timeline. So let's just create an easy DAC and live scope so we can take a look at this. So we turn this on, and we also need to turn on the transport, so I'll just do that real quick. Make a transport. And then I can rewind. So it'll always start from wherever it was paused. Let's move on to creating a more robust setup. We're going to start with just putting these objects together, and let's talk about what exactly is going on. Okay, now that we have this set up, let's talk about each component one by one. So first, you'll notice that I didn't put the lock 1 on this time, so I'm just letting the phasor run by itself. And if you remember from the previous advanced MIDI sequencing video, the metro would not output the bangs unless with tempo relative values unless the transport was running. But it's actually different for phasor. Phasor will output those when the transport is not running. So if I just turn the audio back on, it's running with no problem, even though the transport is off. So that is a difference. You can get the phasor to only run when the transport is on by using the lock 1 attribute. So this phasor is going into swing. So what swing does is it subdivides the phasor, so it breaks it into 2 components. So that means what we have to do is if we want eighth notes, we're going to have to use quarter notes because swing is going to subdivide the phasor, which means it's going to run faster. So again, if you want to have eighth notes, you have to give it quarter notes. If you wanted 16th notes, you would have to give it eighth notes, etc. So you have to keep that in mind when you're working with swing. But the really nice thing about swing is it makes it really easy to make swing, and also it gives you shuffle as well for free. So a value of 0.5 gives you just regular straight values for the rhythm. A value larger than 0.5 gives you swing, it goes up to 0.85. And a value lower than 0.5 gives you shuffle. So that just changes the length of or the proportion of the length between the first and the second subdivision of the incoming phasor. You'll notice that I also put in this sync update attribute and put it on 1. And that makes it so that the swing value will only update when the phasor resets, and that's useful to make the signal less jumpy. You don't have to do that, but I think that it runs a little bit better if you include that. So let's take a look at what's going on here exactly. So we've got our phasor and then swing. Let's take a look at what this looks like. Turn on the audio first. So you'll notice that we have out of phasor, we have our quarter notes, and then out of swing, these have been turned into eighth note ramps, so they're dividing it 2. And then I can play with the swing, so if I go all the way down with shuffle, the first division is really short, and then the second one's really long, and then it'll be the opposite. If I go up from 0.5, you get a longer first subdivision and a shorter second subdivision. So what we'll do is take these phasors, these ramps, and convert them into impulses. And what we can do with those is very easily use edge to get a bang every time it gets an impulse. the left output, or that left outlet outputs a bang when there's a 0 to non-zero transition, which is what's happening here. We're getting a single 1 value going from 0 to 1 when the phasor resets, or the ramp goes back around to 0. And then we can just send that to the counter. And if we wanted to add some of the capabilities that we looked at in the previous video, like turning this into step indices, then you can do that based on the logic that we established before. And just like when we were looking at kind of the absolute versus relative timing, you can reset this clock at any time by sending a 0. So what this does is it resets the phase of the phasor back to the beginning of the ramp, so back to 0. And at the same time, it's going to be sending a 0 to counter to have the counter start at 0 again. So that way we can reset the clock. Hope you found this useful. Please let me know if you have any questions or comments. In the next video, we're going to be looking at ratcheting and how to implement that using MIDI. So until next time, class is dismissed.